Welcome back to my channel. I'm Ricky. Today I'm so excited to talk about an important tool in the welding area. That is handheld laser welding machine. And in this episode, I would like to deeply talk about the laser welding machines, the structure, types, and working principle. So let's get started step by step. As I mentioned before, I would like to use the AI to generation the content and with the AI voice. Hope you understand and like it.
The handheld laser welding machine. This technology is not just an upgrade from traditional welding, it is actually a completely different welding logic based on high-energy laser interaction with metal. In this video, I will explain in a very clear and practical way what a handheld laser welding machine is, how it works internally, what components it includes, how different laser types affect performance, and how to select the right configuration. This will be especially useful if you are a factory owner, a technician, or a sales engineer. Let's go step by step. What is handheld laser welding? A handheld laser welding machine is a device that uses a high-energy laser beam as a heat source to melt metal locally and form a weld joint. Unlike traditional welding methods such as arc welding, MIG welding, TIG welding, laser welding has several key characteristics. First, the energy density is extremely high, which means the material melts almost instantly. Second, the heat-affected zone is very small, so deformation is minimized. Third, the welding speed is significantly faster, especially for thin and medium-thickness materials. Fourth, the weld seam is smoother, cleaner, and requires less post-processing. Because of these advantages, handheld laser welding is widely used in stainless steel fabrication, sheet metal processing, automotive parts, kitchen equipment, advertising signage. And with the cost of laser sources decreasing in recent years, this technology is becoming more accessible to small and medium-sized businesses. Chapter 2, Basic Components, Detailed. Now let's break down the structure of the machine. A handheld laser welding system is not just one device. It is a complete integrated system. Laser source. This is the core energy generator. It produces a laser beam with specific wavelength, high coherence, high energy density. The stability and quality of the laser source directly determine welding quality, penetration depth, consistency. Cooling system. Laser operation generates a large amount of heat. If not properly cooled, performance will drop. Components may be damaged. There are two cooling methods: water cooling, higher cooling efficiency suitable for high power machines, 1500 watt to 3000 watt, supports long continuous operation. Air cooling, simpler structure, smaller size, easier maintenance, but limited cooling capacity. Control system. This is the brain of the machine. It controls laser power, pulse frequency, welding modes, safety logic. A good control system ensures stable output, repeatable results, easy operation. Nav laser welding gun handheld head. This is the part the operator directly uses. It performs several key functions: focusing the laser beam, shaping the energy distribution, delivering shielding gas, sometimes enabling beam oscillation. The design of the welding gun affects user comfort, welding precision, final weld appearance. Wire feeding system. This is used when filler material is required. It feeds welding wire into the molten pool at a controlled speed. This is especially important when there is a gap between materials. Higher strength is needed. Shielding gas system. Shielding gas plays a critical role. It prevents oxidation, stabilizes the molten pool, improves weld quality. Common gases: argon, nitrogen. Chapter 3, Working Principle. Now let's understand the actual welding process. The process can be described in several stages. First, the laser source generates a high-energy beam. Second, the beam is transmitted through optical components into the welding gun. Third, The beam is focused onto a very small spot on the metal surface. At this point, because of the extremely high energy density, the metal melts instantly. A molten pool is formed. Then, the laser continues moving along the joint. The molten pool follows the laser. Finally, the molten metal solidifies rapidly, forming a strong weld seam. Because the heating and cooling are both very fast, grain structure is refined, distortion is minimized. NAP Chapter 4, Types of Laser Sources. This is one of the most important parts. Different laser sources lead to completely different machine performance. 1. Yagi laser. This is an older technology. It uses ND-YAG crystal pulse laser output. Characteristics: suitable for precision welding, good for small parts. Limitations: lower efficiency, shorter lifespan, higher maintenance. So today, it is mostly used in niche applications. Number 2, fiber laser, mainstream choice. This is the dominant technology today. It combines optical fiber transmission, semiconductor pumping. Advantages: very high efficiency, excellent beam quality, deep penetration, low maintenance. It can generate very small spot size, extremely high energy density. That's why it is widely used in industrial welding, automotive manufacturing, metal fabrication. Number 3, semiconductor, diode laser. This type uses semiconductor laser modules. Key characteristics: more uniform energy distribution, higher absorption rate for metals. Advantages: stable welding process, smooth surface, low spatter. Best for thin sheet welding, appearance-sensitive products. Chapter 5, Cooling Classification. During operation, heat management is critical. Hash water-cooled systems. Use circulating coolant, high cooling efficiency, suitable for high-power continuous welding, but larger size requires maintenance, coolant replacement. Air-cooled systems use fans and heat sinks, compact design, easy to move, but affected by ambient temperature, not suitable for heavy-duty welding. Chapter 6, Specifications and Selection. Choosing the right machine depends on your application. Power selection. Common power levels: 500 watts, 1000 watts, 1500 watts, 2000 watts, 3000 watts. General guideline: thin sheet 3mm, 1200, 1500 watts, medium thickness 5mm, 2000 watt, thick materials 5mm, 3000 watts. Laser output modes: continuous wave, pulsed, quasi-continuous. Different modes affect heat input, welding precision, material compatibility. Beam oscillation, very important feature. Modern welding heads support oscillation. Common patterns: circular, linear, figure 8, function. Increases weld width, improves gap tolerance, enhances weld appearance. Chapter 7, Wire feeding methods. Laser welding can be, without filler, autogenous welding, used when parts fit perfectly, no gap. With filler wire types: single wire, double wire, triple wire. Multi-wire is used when gap is large, higher strength is required, faster filling is needed. Conclusion. To summarize, a handheld laser welding machine is a high-efficiency, high-precision welding solution. Compared to traditional welding, faster, cleaner, easier to operate. And with the development of fiber laser technology, it is becoming the standard solution for modern metal fabrication. If you are considering upgrading your welding process, this could be the right direction for you.